Welcome to Motorola's RF design and management software product demonstration. Our suite of design, measurement, and management software includes Enterprise Planner, LAN Planner, Site Scanner, and Mesh Planner. This software is a key component of Motorola's wireless network design process, which helps organizations design a wide variety of multi-band indoor and outdoor wireless networks, including Wi-Fi, 3G, CDMA, GSM, IDEN, Mesh, and even user-defined frequencies. Motorola's wireless network design process consists of 4 key phases: requirements gathering, design, deployment, and verification. Companies that use this approach reduce the amount of time and expense involved in network design, decrease the unknowns in the deployment process, and rapidly resolve any post-deployment challenges. The resulting wireless networks provide superior coverage, capacity, and overall quality of service for some of the most demanding applications, even in complex RF environments. With Motorola's RF design and management software, you produce wireless networks with better performance by design. Motorola Site Scanner software enables rapid measurement of wireless networks and allows wireless LAN managers to validate that networks are meeting coverage and performance expectations. It allows field teams to identify any external factors that may impact Wi-Fi quality of service, visualize the coverage, noise, signal-to-noise ratios, and channel usage in the deployment environment, and to locate rogue equipment that users may have installed in the facility. Let's take a look at the software in action. First off, Site Scanner supports many different types of building map inputs. For example, a user can input an AutoCAD file, a JPEG image, a bitmap image, or many other common file types. Here you can see an AutoCAD building map of Motorola's facility in Austin, Texas. Site Scanner contains 4 major pieces of functionality: record new data, import survey data from other runs, visualize survey data results, displaying wireless LAN heat maps, and the ability to run a report. We'll start with the record new data feature. In this first window, we can configure the measurement run name, the file location, and the channels that will be scanned. In the second dialog, you can see in the left-hand column all of the 802.11bg channels, and in the right, all of the A channels. I'll deselect the A channels and also set the dwell time, how long we scan for a given beacon. The receiver height is also about 4 feet. When we click the next button, you'll see the pane is split in 2, and the lower pane is populated with all of the access points that the card is able to pick up. You'll see across the top all of the information that we collect for all access points, including the MAC address, power, channel, and even if they have WEP turned on or off. All of these access points are updated every few seconds. The user then has the ability to click on the Configure Authorized List button and define if these access points are authorized, in the case of these WVC access points, or unauthorized, as will be the case with the rest. We'll move those to the unauthorized list. Anything left over will be in the rogue MAC list. Next, you can see all of the icons change next to the access points. The access points with an exclamation mark indicate unauthorized, and the regular AP icon indicates an authorized AP. The views can be filtered so that you can see only authorized or perhaps only unauthorized. You can even look at just rogue access points, any APs we've yet to define as either authorized or unauthorized. I'm now going to show all visible APs again, and now we can start collecting some measurement data. To collect measurement data, you can choose single marker mode, where we zoom in and simply click to identify our location in the building. You'll notice that each time the user clicks the mouse, a marker is placed within the building to identify our location, and each marker embeds all of the data contained for the access points displayed below. If instead you'd like to walk down a hallway, simply choose Track Run, and then identify your starting position. You'll notice a red marker is placed. Now, we simply walk down the hallway. You'll notice the track count continues to go up as we're collecting data, and we click to identify the endpoint. All of our data is then placed in between. The user can continue walking, and as they get to the end of the next hallway, simply click the left mouse button again, and all the data is laid down in between. You'll notice here that we can also pause a run, and if we want to, we can go back and undo any of the runs that we've selected. So I can undo an entire measurement run, or simply just one marker. Site Scanner also supports the import of previous measurement runs. Oftentimes, companies will have multiple field service reps collecting data, and all of the data can be returned and all imported at the same time into a single building map. Here you can see a measurement run that's been imported. All of the purple dots represent measurement points, and if you mouse over those points, you can see the data, including MAC address, signal power, and even noise. Now we can turn on a visualization, a heat map that shows the coverage throughout the entire floor plan here that we're interested in. In the right-hand pane, you can see all of the colors and how they correspond to signal power. Here we'll center the map a little bit, and now we can continue looking at coverage. You also have the ability to look at channel, SNR, SSID, data rate, and even noise values. Next, below, you'll see all of the access point MAC addresses listed out by their SSID. I'm now going to turn off all the SSIDs with the exception of the WVC access points and click the refresh button. Now the heat map shows only the coverage by the two APs in the WVC SSID. We can see some areas of the building have very good coverage and some not so good, for instance in the blue areas. Next, we can select just to show the negative 65 dBm and above power boundaries, perhaps for a voice over IP installation. You can see with this restriction that we have some obvious coverage holes where we wouldn't have before. This indicates we might want to go in and place some additional equipment. Now we can clear the map again, and here we'll add back the dockable legend window. Next, I'm going to select, instead of coverage, to look at channel. When we select the channel option, the map becomes colored in so that you can see by color the different types of channels that are dominant in any given area of the building here. If we want to visualize 802.11bg, we simply make the selection from the drop-down, and now you can see in the right-hand pane channels 1 through 11 and where those are dominant within the building. We can even mouse over a given point and see at that particular point in the building what channels are present and at what power. Now let's take a look at how we could locate a rogue access point in the facility. I'm going to select a single MAC address in the left and click refresh. The map will update and show us coverage from just that single access point. You can see that the area of strong coverage, even narrowing down into the red dot, indicates where the rogue access point most likely is in the facility. If we wanted to see its coverage area, perhaps out to negative 80 dBm, I simply enter that value and click refresh. Here you see the coverage area of the rogue AP to negative 80 dBm. I'm going to exit out now from the visualizations, and we'll take a look at the reports. The report shows in a table all of the MAC addresses, their standards, power, channel, even SSID, and further down we can see all of the scan channels and the dwell times. Thank you for viewing our RF design and management software demonstration. For more information about this or other Motorola products, please contact us using the information provided. With Motorola's RF design and management software, you produce wireless networks with better performance by design.